All right, so we are going to look at the odd problems, just the odd problems for the review for exam 5, which is unit 9. Okay, so problem number 1, when I'm looking at to express 64 to the 3 halves as an integer, remember the number in your denominator. Let me zoom in a little closer. The number in your denominator, that is the root that you're taking. So I'm going to take the square root because it's a 2. And then the number in the numerator is your power. So I'm going to raise it to the 3rd power. And you can do it in either order. I always look at the root and say, can I take the square root of 64? Because if I can make that number smaller, I want to work with a smaller number. I don't want to raise 64 to the 3rd power. I don't want to multiply it to itself 3 times. Okay? So I see that 64 is a perfect square. So I'm going to think of this as the square root of 64. And then we're going to raise that to the 3rd power. The square root of 64 is 8, and we're going to raise that to the 3rd power. I'm going to use my handy list on the board. This is 2, 3, 4, 5, 6, 7, 8. 8 to the 3rd power is 512. I will not erase that between now and testing. Okay? We're going to skip number 2 and go, we're going to skip number 2 and go to number 3. But any questions on number 1? Okay, let's go to number 3. Number 3, very similar problem. Number 3, I have my cube root, and I'm raising to the 4th power. So I'm going to check first my root. Can I cube root 27? Yes. So I'm going to do that. 3rd root of 27 raised to the 4th power. What's the cube root of 27? 3. Now, I don't have perfect fourths on the board, so what I'm going to do is just multiply it out. 3 times 3, 4 times. The easiest way for me to do that is to say 3 times 3 is 9. I have 2 of those. So then 9 times 9 is 81. Questions on 3? All right, we're going to skip 4 and we're going to go to 5. Number 5, the expression, the cube root of x to the 12th, y to the 3rd, z to the negative 9th times the square root of x to the 4th, z to the 24th, can be written in the form x to the a, y to the b, z to the c. What are the values of a, b, and c? So remember the root, if I have the 3rd root, I can think of that as everything inside it raised to the 1 over that root power. So if it's a 3rd root, 1 over the 3rd power. So that's what I'm going to do. I'm going to take my x to the 12th, my y to the 3rd, my z to the negative 9, and I'm going to raise that to the 1 to the 3rd power. That's the same as cube rooting it. Then my next one, I don't have a number here. So if there's not a number, that means it defaults to a square root. So I'm going to take my x to the 4th, my z to the 24th, and I'm going to raise that to 1 over 2 for square root. When you raise powers to another power, you multiply those exponents. Okay? So when I multiply my exponents, I'm going to get x to the 12 times 1/3. What's 1/3 of 12? 4. And then y to the 3rd times 1/3 is going to be 1. You don't have to write the 1 there, right? It's just y. But you can. It doesn't hurt anything. Z to the negative 9 to the 1/3 becomes z to the negative 3. Then we're going to multiply the 1/2 to each one of those. So 1/2 times 4 is going to give me x to the 2 or 2nd or squared. And then z is going to become z to the 12. When you're multiplying, not raising to another power, but you're multiplying 2 of the same variable with exponents, you add your exponents. So I'm going to have x to the 4 plus 2. There's only a y in the first term, so it just stays y to the 1st. And then I'm going to have z to the negative 3 plus 12. So that's going to be x to the 4 plus 2 is 6. Y to the 1st is just going to stay y to the 1st. And z to the negative 3 plus 12 is z to the 9.
How did you get the 4 plus 2?
4 plus 2. X to the 4th, x to the 2nd. 4 plus 2. I only have a y in the first one, so I keep the y. And then negative 3 and 12. Negative 3 plus 12. Okay? It says, what are the values of a, b, and c? So x to the a is going to be x to the 6th. Y to the b, y to the 1st. And z to the c, z to the 9th. 6, 1, and 9 are my a, b, and c. Questions on number 5. Okay, let's go look at number, yes, let's go look at number 7. Number 7, determine the domain and range of the function f of x equals, huh? That's in the recording now.
Sorry.
It's your recording. All right, f of x equals 3x minus 2 over x plus 4. So this is going to be one of the graphs that's going to graph, right? It's going to be a rational function, so it's going to do something like this. It's going to have a horizontal asymptote. It's going to have a vertical asymptote, okay? So if I think about the domain and range, my domain, because it's going to keep going this way on my x's forever, and it's going to keep going that way on my x's forever, it's going to be all the x's except for the vertical asymptote, right? It's going to be my domain. So I need to know what is the domain, what is the vertical asymptote, because I'm going to say it's all the x's except for this one. So if I look up here on my poster, my vertical asymptote is when the denominator equals 0. So my vertical asymptote is when the denominator equals 0, so x plus 4 equals 0, x will equal negative 4. So that means I can be all the x's except for negative 4. So my domain is going to be all the x's except x cannot equal negative 4. Now, I don't know how they would have the answer choices to select for this one. They might have all the x's except 4 and you would type in a negative 4. Or they might have this as an A, B, C, D choice. They could also have it in interval notation, which would mean it can be all the x's from negative infinity up to negative 4, but not including it. In addition, starting at negative 4 but not including it all the way to infinity. So those both mean the same thing. One's just a lot longer way to write it. Okay? My range is going to be all my y values because I have this down arrow here, so I know it's going to keep going down forever. And I have this up arrow here, so I know it's going to keep going up forever. The only place we're not going to have a y value is going to be at this horizontal asymptote. So my range is going to be all the y values except for the horizontal asymptote. So when I look at this problem and I want to know what the horizontal asymptote is, if I go and I look at number 3 on my poster, my horizontal asymptote, I compare the degrees. Same degree, bottom heavy degree, or top heavy degree. What do I have here? I have the same degree. They're both x to the 1st. So I have the same degree. So I'm going to look at y equals the ratio of my leading coefficients. My leading coefficients are 3 and 1. What's 3 over 1? 3. So that means my y values are everything except for 3. Bless you. So my range is going to be y equals everything, but y does not equal 3. So again, you can write it like that, or you might see it as negative infinity to 3. And then 3 to positive infinity. You could see it either way. Questions on 7? Okay, let's go look at number 9. Huh? Okay. Number 9, the expression 4x minus 9 over 4x squared minus 9 over 2x squared minus 3x times 3x squared minus 17x plus 10 over 2x squared minus 7x minus 15 can be expressed in the form ax minus b over x. Find the values of a and b. So they've clearly taken this, they've done the multiplication, because I no longer have multiplication over here, and then they've simplified. So what I need to do is I need to factor both my numerators and both my denominators and then see what eliminates. Okay? When I look at the first one, I see 4x squared and I see 9, and my brain is like, oh, well, 4 is a perfect square, 9 is a perfect square, and x squared is a perfect square. This is a difference of squares, right? So when I square root 4x squared, that just leaves me with 2x. And when I square root the 9, that leaves me with 3. So it's going to be 2x minus 3, 2x plus 3. That's my first numerator. Then my denominator for that first fraction, 2x squared minus 3x. I don't have a difference of squares there, but I do have an x in both terms. So I can take an x out of both of those terms, which is going to leave me with 2x minus 3. So I can already see those first two are going to cancel out, right? The 2x minus 3's. Then I have multiplication. If I had division, I'd have to flip these over, right, after I simplify them. But I have multiplication, so I get to leave them as they are. Because I have a 3 in front of this x squared, I'm going to have to factor by grouping, which means I'm going to come off to the side to do that because I'm not going to be able to go straight to writing it here. If I had a 1 there, it would be simple and I could go straight here. But I don't. I have to take my outside terms, my 3 and my 10. I'm going to come off to the side over here. And I'm going to multiply these two together and get 30, a positive 30. My factors of 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6. I want to get a negative 17 in the middle, but I want this to be a positive 30, which means my two numbers have to both be negative, so they multiply to a positive. 2 and 15, 15 and 2, whatever order you want to say it in. Okay, so then I'm going to rewrite it, but instead of writing minus 17x, I'm going to do a minus 2x and a minus 15x. So 3x squared minus 2x minus 15x, that's my minus 17x when I combine like terms, plus 10. And then I'm going to factor that by grouping. So I'm going to take these two together and these two together. What can I take out of both these first two terms? An x. That's going to leave me with 3x minus 2. So that's what I need to have left over here. I need to have the same thing left. What can I divide the negative 15 and the 10 by so that I get a positive 3x and a negative 2? Almost. Negative 5. So that negative 5 times 3 is my negative 15, and negative 5 times negative 2 is my positive 10. Okay? So I can see they both have a 3x minus 2. And then I'm factoring out the x and the minus 5. So that's my numerator for the second fraction. It is 3x minus 2 and x minus 5. Now I need to do the denominator. And again, because I have a number in front of my x squared, I'm going to have to do factor by grouping. Okay? My two outside numbers are 2 and 15, so it's still 30, but this time it's a negative 30 when I look at my 1 and 30 and my 2 and 15, 3 and 10, and 5 and 6. I'm looking for a negative 30, so only one of them's negative, and I want to make a negative 7 in the middle. Negative 10 and 3. That's what I used for the first one. Okay? So I'm going to take my 2x squared, and then my negative 7x, I'm going to divide it up like this, my plus 3x, my minus 10x, and then I have my minus 15. So I uncombined my like terms, right? All right, so now factor by grouping my first two terms, my second two terms. I can take, just like last time, I can take an x out of the first one, leaving me with 2x plus 3. So I still want to end up with a 2x plus 3. What am I going to have to factor out of my negative 10x minus 15 to make it a 2x plus 3? Yeah, negative 5 again. Because negative 5 times 2x is negative 10x, and negative 5 times 3 is my negative 15. So I'm going to factor out the 2x plus 3 and be left with x minus 5. That's my denominator for the second fraction. 2x plus 3 and x minus 5. Okay, so now I can see what cancels out. When I look at this, canceling out is going to be the 2x minus 3 on top cancels with this 2x minus 3 on the bottom. The 2x plus 3 on top cancels with the 2x plus 3 on the bottom. And the x minus 5 on top cancels with the x minus 5 on the bottom. If I was going to graph this, it would have 3 holes in it because there were 3 things that canceled out. I would be left with on the top just 3x minus 2. And on the bottom, I'm left with just x. So when it says find the values of a and b, a is in front of x, that's my 3. And b, it says minus b, so minus b must be 2. Be careful when you do these. Sometimes when I've looked at the quiz answers, instead of putting a minus here, they'll have a plus, but here you'll have a minus. So if this had been ax plus b, then for b we would put a negative 2. Does that make sense? But since the minus was already there for me, it was just the positive 2. Okay? Questions on 9. Let's go look at 11. All right. The function graphed below can be expressed in the form a plus x times x minus b over a plus x times x minus b times x minus c. When you see something repeat in the top and the bottom, we know that that means that would cancel out. And on the graph, do you remember what that produces on the graph? It produces a hole. So my x plus a produces a hole, and my x minus b produces a hole. If you have anything left on the top, that would be an x-intercept. We don't have anything left on the top. If you have anything left on the bottom, that would make you undefined if that's 0. So that gives you your vertical asymptote. So when I look at my graph, I can see I have a hole right here at 2. I have a hole right here at negative 3, x value of negative 3. And I have a vertical asymptote at x equals negative 1. What do you want to start with? Which hole, the negative 3 or the 2? 2? So what would I put in here that would cancel out, that would make that hole? Would it be x minus 2 or x plus 2? X minus 2? So when x minus 2 equals 0, that's going to give me a hole of positive 2, yes? Yes. So that needs to repeat on the top and the bottom. Because that way when I put a 2 in, 2 minus 2 is my 0. All right, what about my other hole, my negative 3? What's that going to look like top and bottom? X plus 3. So then we still need to do our vertical asymptote. My vertical asymptote is going to be x. X plus 1. Okay, so now when I'm trying to find A, B, and C, did we write ours exactly the way they wrote theirs? No, my x minus 2 is really that 2 goes for what letter? X minus 3 goes with A, B, or C? B, because it's a minus B. That's the only place I have a minus. B has to be 2. And then what's my A value going to be? What's the positive one on top and bottom? 3. And then the one that's only on the bottom is? Let's go with 1. Yes?
So for the x minus 2, since when we said b equals 2, since that one became positive, what is the 3 become negative? A equals negative 2?
A equals, no, it's the same as x plus A, x plus 3. A is 3. Does that make sense? The reason it changed from here to over here is because this that cancels out, x minus 2 equals 0, makes x equal 2. right? This right here, my x plus 3 equals 0, makes x equal negative 3. That's where I have a hole because those cancel out. And then my x plus 1 being all by itself on the bottom, if I do x plus 1 equals 0, so I have a 0 in the denominator that doesn't cancel with anything on the top, means I have a vertical asymptote at negative 1. Okay. All right. Questions? Any other questions on number 11? Okay. Let's skip to number 13. Number 13, solve the equation for x. Whenever you're trying to solve equations that have roots in them, you have to get the root all by itself. So I have to get rid of that 3 that's being added to the root. How do I get rid of this 3? Subtract it. So that's going to give me 2 equals the square root of x plus 2. How do I unsquare? How do I unsquare root? Square. Squares and square roots cancel each other out. 2 squared is 4. That's going to equal just x plus 2. Then what? Subtract 2. That's my subtraction property of equality. And 2 equals x. Now, before we put a box around it, remember your square root equations can have extraneous solutions. So we just need to double check. Check that x equals 2 really does work in my equation. So 5 equals 3 plus the square root of 2 plus 2. 2 plus 2 is? Square root of 4 is? And 3 plus 2 is?
5.
Yay! So x really does equal 2.
If it didn't on the test, would we just write it?
No solutions.
Oh.
Or extraneous solutions. Okay? All right, number 15, unless there's any other questions on 13. Okay. Number 15, write an equation that has all of the features listed below. Okay? It has a vertical asymptote at 4 and negative 2. So that's where my denominators are undefined. So that means in my denominator, I've got 2 expressions that can't equal 0. If I want x to equal 4, what do I need to put in there? X minus 4. And if I want x to equal negative 2, what do I put in there? Plus 2. Okay? X-intercepts, that's where the numerator is 0. If I look over here in my poster number 5, x-intercept, that's when the numerator is equal to 0. So for these two things, just like before, I want to get a 0 in the numerator. So if I need x to be a negative 3, what goes in here? Plus 3. And if I need x to be an 8, what goes in here? Minus 8. Now this is the one that can throw us off a little bit. A y-intercepted 0, 15. That's to get us to check to see if there is an a value. If there's something being multiplied in front of this. So I need to check and see, do I have an a value? Or is it just 1 times all of this? Okay. Here's how we find out if we have an a value. I need to go through the point 0, 15. So when x is 0, y is 15. So I'm going to substitute in for y a 15. And that's going to equal a times 0 plus 3, 0 minus 8, over 0 minus 4, 0 plus 12. I just changed all the x's to zeros, and when x is 0, y should be 15.
2.
2. That's the second time today I've done that. 2. All right, I'm going to come up here because I ran out of room. 15 equals a times 0 plus 3 is 3, 0 minus 8 is negative 8, over 0 minus 4 is negative 4, 0 plus 2 is 2. So 15 equals 3 times 8 is negative 24a over negative 4 times 2 is negative 8. 15 equals negative 24 over 8, or no, negative 24 over negative 8, positive 3. A. How big is A? 5, right? Divide both sides by 3, and you get 5 for your A value. So to write the equation, we're going to write this equation, but now we know that A is 5. So y equals 5 times x plus 3 times x minus 8 over x minus 4, x plus 2. If this problem had any removable discontinuities, it had any holes, like the next one does, where I have x equals 2, that means I'd need an x minus 2 in the top and an x minus 2 in the bottom, right? Your horizontal asymptote, if you have the same number of factors as you do in the top and the bottom, so I've got x and x, so that's an x squared, x and x, so that's an x squared, so that's going to be x squared over x squared. You'll have the same degree. It should be the ratio of the lead coefficients. Like this one, I have a horizontal asymptote of 5. What's nice is on this one, as long as you have the same number of x's as you do in the top and the bottom, then this horizontal asymptote is going to give you the A value. You don't have to compute it like we did in the you can, you'll get the same answer. Okay? So and that's only if you have the same number of x's in the top as you do in the bottom, right? The same degree. Otherwise, you still have to find your A. Either way, it wouldn't hurt to find your A. All right. Any questions on number 15? Okay, 17. What is the horizontal asymptote of this function? So I'm going to look at my degrees. What's the degree on the numerator? Squared, or 2. What's the degree in the denominator? 3, or cubed. Same degree, bottom heavy, top heavy. Bottom heavy. I don't know that that's an official term, so if you go to like college and you're like, it's bottom heavy, your teacher may laugh. I don't know. But that's what I call it. It sounds wrong, but it's what I call it. All right, so this is bottom heavy, which means my horizontal asymptote is y equals 0. Easy peasy. Questions on 17? Okay, let's look at 19. 19's a fun one. Perform the following operations and simplify. So they have to have the same denominator, which means I'm going to multiply the first fraction by the denominator of the second fraction. So I'm going to do 8 times 1 minus 3x. 1 minus 3x. So that I'm still multiplying by 1 and I'm not changing that fraction. And I'm going to multiply my second fraction by the denominator of the first, 3x minus 1. 3x minus 1. So again, I'm not changing the fraction because I'm multiplying by 1. My numerator, I'm going to go ahead and distribute. Right? So that's already taken care of. So I'm going to have 8 times 1 is 8. And 8 times negative 3 is negative 24x. Over 1 minus 3x times 3x minus 1. Plus 1 times 3x is 3x. 1 times negative 1 is negative 1. Over 1 minus 3x times 3x minus 1. So now they have the same denominator. I can add the numerators together. So I can do 8 minus 24x plus, because I have a plus sign here, this stays exactly as it is, 3x minus 1. But if you notice on number 20, I have a minus sign. So whatever you end up with here, you'll have to distribute that minus. It's going to change these two, the sign on both of them. Okay, so don't forget that when you're working number 20. 3x minus 1 over. I'm going to take this 1 minus 3x and watch what I'm going to do. I'm just going to write it in the right order because we don't like 1 minus 3x. We like minus 3x plus 1. So I still have a negative 3x. I still have a positive 1. I just changed the order so it's in descending order of degree. 3x minus 1. Now I'm going to combine like terms. I'm going to put my x's together first. That's going to give me a negative 21x plus 8 minus 1 is 7 over negative 3x plus 1 times 3x minus 1 equals, can I factor my numerator? Before I do that, I want to see if I can factor, because if I can completely factor anything, then things might cancel out.
Yes.
What can I take out of negative 21x plus 7?
7.
I can take a 7 out of both. If I divide negative 21 by 7, that's going to leave me with negative 3x plus 7. Or sorry, plus 1. I took the 7 out. I forgot to divide it out. Over negative 3x plus 1. Do you see why I didn't want to multiply? So then I can see that my negative 3x plus 1 in the numerator and the denominator cancel out. And I end up with just 7 over 3x minus 1. I'm completely out. You can run the restroom if you need some. Questions on 19. All right, let's look at 21. 2 more. Determine the domain, range, and y-intercept of the following function. So we need to think about what this graph is going to look like. This is not a rational function, so this is not the one that's like the 2 pieces. This is a square root. If I think about the parent function of a square root graph, my parent function on a square root starts at 0. It kind of looks like 1/2 of a parabola that's been turned sideways. Okay, that is the domain, that is the parent function, y equals the square root of x. What happens when inside the function, next to x, I add, oh wait, I forgot, there's typos on these. Fix these typos. This is not a 5. That is really white out. I know it looks like a 5, but it's not. I had white out. I don't know where it went. It is really a 9. And over here, this looks like a plus sign, but it's not. It's really a minus. Fix that typo. And this looks like a plus 2, but it's not. It's really a 4. Fix that typo. So this one is really 4 plus the square root of x plus 9. And this one is really negative 3 minus the square root of x plus 4. Okay? All right, now that I got that out of the way. All right, what happens inside the function when I add to x? Where does my graph move? To the left that many units. So I'm going to be moving left 9 units. What happens when to the function I add 4? Up 4. So that means my function that normally started here at the origin is now going to start at negative 9, 4. But then it's going to look the same from there. So looking at the blue line, not the pencil, that's the parent function, I need to determine the domain. What values of x are allowed? Greater than or equal to negative 9. Which you could see it written like that, or you might see it written as everything from negative 9 to infinity. Both of those say the same thing. I don't know how it's going to be on the test if this is a question on the test. Your range, what's my range? Everything. Yeah, everything's above the 4, right? So y has to be greater than or equal to 4, which you can write like that, or you can write it as everything from 4 to infinity. That's my domain. It also says to find the y-intercept. At my y-intercept right here, what's the x value? When you cross the y-axis, what's the x value? 0. So to find the y-intercept, all you have to do is let x equal 0. So I'm going to call this y instead of f of x. 4 plus the square root of 0 plus 9. Now you see why I wanted to change it to 9. Y equals 4 plus 0 plus 9 is just 9. What's the square root of 9? 3. And so y equals 7. So this is going to be the point x is 0 when y is 7 when x is 0. That's my y-intercept. Y-intercept, domain, range. Questions? Okay. Last one, number 23. Number 23, the average energy produced by the number of widgets, that should be an S, widgets made is expressed by this function energy of the number of widgets is equal to 3 widgets minus 2 over the number of widgets plus 4. As the number of widgets gets extremely large, what will the average energy produced approach? So, I don't know what a widget is. No idea. It could be a thingamabob or whatchamacallit. I don't know what a widget is, okay? But I do know that if I see a graph set up like this, it's going to be a rational equation that's going to do something like this, right? So as my x values, as the number of widgets gets extremely large, I want to know what value am I approaching? Well, I'm approaching the horizontal asymptote. So this question is just a fancy way of asking, what's the horizontal asymptote? Why they can't just ask that, I don't know. I didn't make the question, okay? So to find the horizontal asymptote, that's easy. I just compare my degrees. What's the degree in the numerator? 1. What's the degree in the denominator? So they have the same degree. So I'm going to look at the leading coefficients. What is my horizontal asymptote? Y equals 3. So that means as my number of widgets gets extremely large, my energy produced is going to be 3 units. The energy produced will approach 3, whatever my units of energy are, ohms or something. Okay? What I would recommend doing is trying to do all the evens on your own. So that way tomorrow when I share the answers with you, you can check your work and see if you have any questions. That would be what I would do.